Hello everyone and welcome to this session of refactoring. Today we are going to look at the art of refactoring and 5 things we need to take care of in this video. I'm Ankit Tanna and welcome back to Everyday JavaScript. Now we know that we can't write good code from day one and we can't write good code from the beginning of the project because even if we are experienced, our mindset is not in that. Our mindset is basically focused in completing the functionality and delivering what our company needs or what our project needs. And we have to rely on refactoring because of this. Now, what is refactoring? Refactoring is basically like polishing a diamond. So, as you know, that the diamond that you get is rough. When it is rough and uncut, it's unpolished, it does not look good. So our bad code is something like uncut or rough diamond. So basically, so basically, it is basically it does not look good. The uncut diamond does not look good, and it is difficult to understand at a later point of time. We need to put a lot of effort to polish it. That's what the problem is. That's what the bad code comes at a price of. If we start writing bad code and if we don't do refactoring exercise regularly, then this is what the price we need to pay for it. And how many times has it happened to you that you might have written the code and forgotten about it, what you have written it, and why you have written the code? Even if the code that you've written is just few weeks ago. So this is what the problem is. The solution is make your code as clear and as informative and descriptive as possible. This is the maximum that we can do to make our code look good, look beautiful, and easy to understand. For not just us accessing the code maybe a few months or years down the line, or someone who is replacing, and it is very good for all the people who are accessing our code, even for the non-technical people. Our task should always be to try to make it so easy that even a functional person or a non-technical person can read our code. It should be as close as to something like a functional behavior of an application. Like, have you won the game? Have you lost the game? Is card valid? Is card invalid? Something that is verbal. Verbal means something that we speak day-to-day basis. So it would be easy for a non-technical person to understand. In this video, we are going to show you 5 technical things to take care of while refactoring. This is a very short video and it will also show you that what 5 things technically you can do inside your code to refactor it, and whenever you encounter such kind of code, what actions can you take. So let's start. Out of these 5 things, the first thing is get rid of the switch statement. Second thing is make your conditional statements descriptive. Third thing is use guard clause to avoid nested if statements. Nested if statements should be avoided at all costs. Avoid code duplication, something that we often see. And functions should do only one thing, that is single responsibility principle. And that's the best thing that you can do in refactoring. These are the 5 basic exercises that you need to do in all the refactoring stuff. So let's start with the first thing, getting rid of switch statements. How many of you love the switch statements, or how many of you love switch cases? Basically because, one second. So how many of you love switch statements? I love the switch statement because one of the reasons is it's available in all the languages. It's available in JavaScript, it's available in C, C++, it's available in Java, probably any other languages that you see out there. Switch syntax would be available. The problem with this is it has kind of like an odd syntax, and it is kind of like difficult to test also. There is a lot of manual involvement available inside the switch syntax, and you also have to add manually a break statement after each and every case that you write. So that makes it error prone since a human involvement is present over there. Also, it is quite verbose. All that we need to avoid in our code is verbosity, because the reason is the things can get quite complex. Let's take an example of simple get Pokemon example. So I'll just go ahead and switch over here. Over here, it's a simple function which gets me the name of a Pokemon based on the characteristics that I pass in, like let's say water, fire, plant, or an electric, or a default Pokemon is also available. But as a geeky person, there are 807 Pokemons available. How many of them are you going to write in switch cases? Is it feasible? No, I don't think so. But if you move all these switch cases out into some other place, some common place where it can be accessed readily again and again, since it's not going to change over the period of time, then you can make your life easier. You don't need to write a bulky verbose function which has 807 Pokemon names listed over there. And just remember, 807 Pokemons, then that means that 807 times you'll have to write those break statements. You'll be going mad if you have just missed a break statement in one place. That can cause a bug. So over here, what it does is this function is simple. It has a Pokemon variable, okay, and a switch case based on the type that we pass. So if we pass water, it's going to return Squirtle. If we pass fire, it is going to return Charmander. If we pass plant, it is going to return Bulbasaur. If we pass electric, it's going to return Pikachu. Any so on, and we have a default case as well to take care of, like just in case if someone passes a name which we have not taken care of, or a case which we have not taken care of, what do we need to do? Well, the simplest of the solution for this is use objects or map. We can use objects or map over here. How can we do that? Let's show you. Let me show you. So what I'll go ahead and do is basically this kind of bulky code should not be present inside a function. It should be something that is outside the function. It should be somewhere inside the configurations or some common place. So I'm just going to write const Pokemon equal to, it's an object, okay, and we are going to map the characteristics with the name of the Pokemon. So let's say if it is water, we are going to say Squirtle. If it is fire, we are going to say Charmander. If it is plant, we are going to say it is Bulbasaur. If it is electric, we are going to say Pikachu. If it is anything else, it's going to be Mew, the default Pokemon. Now, as you know, we have more than 800 Pokemons available. You can write all the Pokemons over here and then probably export it to some config file that can be imported at a later point of time inside your application. And we can get rid of entire nonsense stuff over here. In fact, we can get rid of this entire 2 lines as well. And what we can do is, all we need is type, and we can say return Pokemon type. Now this is going to access the type. Let's say if we are going to pass water, it's going to return a Squirtle. That's it. But what if we pass something that is unknown, like let's say something like this, something that is not registered? We can handle the default case something like this. So I hope you understand, like switch cases may sound interesting or they may sound very helpful in certain cases, but ideally I would not like to use switch cases inside my JavaScript. Ideally I would never use switch cases unless there is very limited number of conditions and very less amount of things that needs to be done inside the cases. So this is how I can refactor the solution. We can also use maps. There is a feature in JavaScript that is known as maps. How can you use maps? You can create a map like this, new map. Quite easy. A map is an array. It takes an array of arrays. So basically, it takes an array of arrays like this, and it's a combination of key and value. So this array will basically contain two items. Water would be the key, the squirtle will be the value, and we can say fire, Sharmador, and we can say plant, Bulbasaur. And we can say electric as Pikachu. Okay, so we've created a map. Now we'll say how we can access the map. It's quite easy again. You just use .get and you send type. So over here it will work exactly how the objects used to work. And if you pass fire, it will return Charmander. If you pass water, it will return Squirtle. If you pass plant, it will return Bulbasaur. And if nothing is present over there, it will return Mew as a default case. So basically two different ways of refactoring your switch statements, and it's quite easy to remove the switch statements totally altogether from your entire code base. Next thing is descriptive conditions. Now, descriptive conditions are quite important. The reason for this is the reasons for this is conditions can get quite complex very easily, but they always can be functionally represented by a verb. That means that, just as I said, is task completed, is game won, is game lost, is even number, is odd number. The function that we represent over there, like is task completed or is game won or lost or is even number, is a unit, and it is easily testable. It's a very small function which will contain only that logic of the condition, and it will give you either a truthy or a falsy value. So basically, this one would give the developers nightmares after 2 weeks of writing it, because the person would not remember what is remaining triple equal to 0 means, and remaining triple equal to 1, and the remaining players triple equal to 1, and what does remaining players triple equal to 0, and the OR condition amongst all these three sub conditions mean. So what you can do is you can take this entire junk out, and then you can push it inside a separate function. So basically my idea is I'll take this over here, I'll go ahead and create a small function, is game lost. Basically this is a condition to check whether the game is lost or not, and we'll return the condition. So basically I'll add the round braces over here and I'll complete it. This is my entire condition fixed into one small function. This function is unit testable, so you can just play around with this function by setting different parameters for this function, and then you can test it easily. All I need to do is, now just imagine how easy has it become for a person who is reading this code. Check game status. If you have lost the game, you quit the game. That's it. That's what I meant by making your code more closer to functional stuff that you do inside your application. You must be able to incorporate those verbs inside your application. So this is check game status. And this is how we refactor the complex conditions inside a function. We extract it into a small function again. The third thing that I want you to take care of is guards. Okay, guards inside a nested if. Nested if is a terrible, terrible thing to do to a developer that might be replacing you. It is a nightmare for the person who is coming after you, or it is a nightmare for you yourself because you might have forgotten why you have written an if inside an if inside an if. So it becomes quite difficult for you to recall all those stuffs, like why this has been written like this, why that has been written like that. So what you need to do is avoid nested ifs as much as possible. How you can do that is basically understanding how function works. One one thing that I have observed is it becomes a nightmare if you have a nested if. And once in my career, I had observed an if with a nested level of 10 levels inside each other. That means that you repeat it 10 times, if inside an if inside an if inside an if. You can just imagine how complex it is. So basically you need to find out the exit points of your functions, like basically a place after which, a condition after which the function will not execute. Once you have found it out, you need to cover it with a guard. What is a guard? A guard is a Boolean expression that must evaluate to true in order to continue to execute that branch. So that means that if you want to execute that particular piece of code inside that function, you are protecting it with a guard. That is a boolean that needs to be true if you need to execute it. Very simple, right? We call this as guard. Placing it early in the function, again, this is one of the tricks. You have to place it at the highest point of your function before the rest of the common code executes inside your function. Since those codes are the exit points of your function, so you don't want your common code to execute before your guards have come into picture. So your guards and the exit point should be at the topmost level of your function. So let's take an example of the problem statement. We have a function, we have a function write tweet over here. So now in this write tweet, what we are doing is we are checking if it is logged in, if the person is logged in or not. Then if we check if the tweet is existing or not. Then if we are checking that if the tweet is double checked or not. And then if it is possible, we'll tweet it. Else we'll throw an error. Okay. And outer else condition of if the tweet is existing or not, or if you have written something in the tweet or not, you're going to check another thing and you're going to throw an error. An outer condition of that is if you're logged in or not. So we can easily find out the three exit points of your entire application or entire function. So basically, if any of these three error condition happens, I don't want you to execute my function. So basically, I'll just go ahead and come over here. Firstly, I'll just understand functionally. Even though I don't know much about this function, I just will try and say that if negation is logged in. So if my user is not logged in, I will say that you need to log in before you tweet. Exit point. You don't need to execute after this. So I can say return probably. Next, I need to check if there is a tweet existing or not, because that's the second condition that you are checking after the logged in functionality. So I'll say if tweet is not existing, the negation means negation of falsy, that means tweet is not existing, that means true, that if tweet is not existing, I want you to exit. So I'll say like this. Okay. The third thing that I check is the tweet double checked? That's a quite logical answer. Like if you are not having more than 140 characters, or sorry, more than 200 characters, I think in this case, or invalid characters inside your tweet, or something that you want to check inside your tweet, then we'll say that don't publish your tweet without double checking it, and then I'll say return. And if everything goes fine by God's grace, what we are going to do is, after all these things, we are going to say tweet it. And we got rid of this piece of messy code out of this, and we have written it in a clean manner. So this is what guards can help us in resolving nested ifs. So never ever write nested ifs inside your function. Try to avoid as much as possible, I would say, nested ifs. Okay. The fourth thing that I wanted to show you in refactoring is code duplication, because this is something that we do out of laziness, or probably even do it out of the crunch of time, because there's a deadline on your head, and you need to deliver, and your boss is on your head with a gun, and then he's saying that okay, I need that thing, or he or she is saying that okay, I need this thing by tonight, I need this thing by today, and all you end up is, instead of finding a better solution, you just copy it, paste it, I don't care. So code duplication is something that we encounter many times. Duplicating code always ends badly. How many times, I mean, you have heard this from many people, that I fixed the bug here but forgot to do it there. This is the most common statement you hear, and that's when you realize that there's a code duplication. And then you say that I need to make a change or add a new feature and have it to do it in 5 different places. Like you have copied the code in 5 different places, and then you end up copy pasting here, there, and then you might make some manual mistake because there was a slight tweak in one of your 5 functions that you copied, and it can lead to a mess. So idea of avoiding code duplication is, every piece of knowledge or logic must have a single and unambiguous representation in your system. Logic should be written only once, or knowledge should be written only once inside your application code. You should not be replicating it. You should be able to find a way to access it again. You should be avoiding duplication of code at any cost. The thing is, less code is very good, as it saves time and effort, and it also gives you happiness to reduce the code. Okay, so the saying over here is quite clear: less code is very good. Lesser the code, lesser the bugs. That's the most truthful saying that I've ever heard in programming life. Like if you have 100 lines of code, you are going to have appropriate number of bugs. So that's what you need to do to avoid duplication in the code. So let's come to the problem statement over here. Now we have a code duplication over here inside this, where we are getting news for different programming languages or different technologies like JavaScript, Rust, or Golang. And what we are doing is, our thing is quite common. We are creating a const array in all the functions, and we are getting the news from the web, and then we are looping through all the news that we get from the web, and then based on the type we are sorting it, and then returning you the sorted news, or basically filtered news. So basically there is few things that are happening over here as a part of duplication. Okay, so first thing that I would like to make something common over here is the loop. It's the most bad thing that I hate in a code, that if loop is repeated again and again and again here and there. The most common thing that I can see over here is the empty array being created, and empty array and array being returned, and the loop. There's nothing special happening over here, here, and here, and there's nothing special happening over here, because all of them are getting the news from the same source. So how shall we do it? Let's say we create a function function get news content, and then we are going to say inside this function we are going to say a constant news array, and we'll return news. Okay, post that what we are going to do is we have to loop through this entire stuff. So basically what we're going to do is we are going to copy this loop and we are going to paste it over here. That means loop is something that is common. Now this entire piece of code needs only two inputs for us to function. That means we need all news, that means the news that we get, and the type of news that we want to filter out. So what we are going to do is we are going to say all news over here and type. So we are going to remove it from here and we are going to say compare it with the type that we get from our function. Once we have done this, we have created a reusable function that can be used in place of this code, and this code. So we have reduced looping. We have reduced an extensive piece of code that had no role being there again and again and again in different function and doing the same stuff. We have also got rid of returning the news because this is what this function will do, and we are going to return it again via this function. So we will remove the return news part. And also we have got rid of the creation of an empty array. So basically we'll remove this. Okay, now all we need to do is, since all these functions were returning news, we also need to return, and then we are going to call this function over here, get news content, which is responsible for looping through all news and the type of news, that is. Next, what we are going to do is, in this function we are going to do it for Rust. In this function we are going to do it for Golang. So basically we have reduced the redundant piece of code that we had to something like this. Now the good thing about JavaScript or any other language is you can refactor it further down, because you see over here there's something that is getting repeated over here again and again and again. The only thing that is different in these three functions is the type that you are passing to this. This is the only thing that is different. Rest everything is common. So what if I did something like this? So what I'll do is I'll remove these functions. I'll say get news instead of this, and I'm going to say get news by type. And all I need to do is, instead of doing this, we are going to say get news by type. So we have refactored a huge lines of code into 16 lines of code. A code which was more than like 50 lines of code to a 16 line of code. It gave a lot of happiness to me by deleting the code. One more thing that you can do is, if you are aware of ES6 features, you could be very much powerful in this area as well. Like if you are aware of filters, you are aware of maps, you are aware of reduce, then you would be able to even refactor these many lines of code, like 7 through 15, 8 lines of code could have been reduced down to 3 or 4 lines of code. Let's try. What we are going to do is ultimately we have to return news, so we'll say return all news dot filter, and what we are going to do is we are going to filter takes one argument in the callback, that is current news, and we are going to say return current news dot type equal to type. So basically we have reduced our 8 line of code to 4 line of code. We can even further reduce since we know how arrow function works. So we are going to reduce it like this. Smaller the code, smaller the amount of data that you need to carry on over the bandwidth towards the client. So basically we have reduced our 50 line of code to 8 lines of code. Very nice, right? Last but not the least thing, it's the functions should do only one single stuff. So that means all the functions should behave like as if they are following single responsibility principle. As you know, single responsibility principle means you do one stuff inside one function only. A function should not poke its nose in order to do someone else's task. If you are designated one task, you should focus 100% on that task and you should do that task only, nothing else. So whenever we are bootstrapping an application, we usually see such kind of code where everything is messed up. We connect to the database, we set the event handlers, we fetch some asynchronous code, we set up some DOM manipulation, we do all such stuff. So tasks which have no relation to each other are placed inside a function which is responsible for bootstrapping of your application. This is what we commonly see in the bootstrapping function. What you should do is segregate them into different functions. Like a function which can be responsible for doing different tasks. Like let's say connection to the database, setting the event handlers, or probably even the printing of all the employer lists. So let's start with the 3 things that I need to do inside this function. Let's go with this line which is not related to any function. So what we are going to do over here is, in the else part, we are going to check the connection to the DB part. Let's take this. I'll create a function. I'll go ahead and write the function at the bottom. So this function will only be responsible for initializing the database. Once this is done, we are going to say these lines of code. Let's say they are responsible for attaching the event handlers. And we are going to write function and we have written the event handlers inside one single function. The last thing that we are doing over here is fetch employees. That is an asynchronous task. So we're going to pull this out and we're going to say fetch employees. And we have successfully converted all our code into small piece of functions which are following single responsibility principle. These functions like initialize database, add event handlers, or fetch employees don't mess around with the different tasks that you have. You'll see that they don't share the common memory or they don't share the execution context as well. That means that you're segregating these functions into simple, small parts. And that is what I meant by single responsibility principle. So all the functions that you create should be responsible for doing only one task, not multiple tasks. So those are the 5 things that I wish to say to you today regarding refactoring and the art of refactoring. And programmers are the only ones who are responsible for writing good codes and quality code. Although we can't do it at the point 1 or step 1 of our programming life cycle of any project, but we should make it a habit of writing a code which is clean. We should make it a habit of at least having a refactoring exercise after each and every milestone that is achieved. That will help you and your team. Writing clean code isn't complicated at all. Doing so will help you both your team and you yourself and saving time. And that's it. And helps it also helps you in concentrating on the functionality. So that's it from today from Everyday JavaScript. I hope you like this video. If you have liked this video, please like, subscribe, and share this channel to your friends and to other development community. And I hope to see you soon again. Thank you.